So we have 50 is less than 7x plus 6 is less than negative 8. We're expected to solve and graph the solution. So what should we do? Yeah, we get rid of the 6 on all the things. Now these compound inequalities, there's not just 2 sides, there's 3, right? So subtract 6 on all of it, right? So what's 50 minus 6? Where's your jacket? Oh, Oracle. I thought it said something totally different. That makes more sense. Okay. 7x is less than, what is negative 8 minus 6?
Negative 14.
Negative 14. Now what? Divide 7 on all the places. What's 46 divided by 7?
Well, isn't it 44?
Well, yeah, that makes more sense. What's 44 divided by 7? 6 and 2/7 is less than x is less than, what's negative 14 divided by 7? Negative 2. Now what? We graph it. What do we do now? 0 on there, sure. Now what? 1, 2, 3, 4, 5, 6. Now what?
Just how well you choose the far side.
You don't necessarily have to. Open circles, closed circles, or both?
Open circle.
X is greater than 6 and 2/7 and less than negative 2. So where are we going to shade?
Inside. Wait, look.
It's greater than this one and less than this one. A lot of times, and you don't necessarily have to, at least in this class, a lot of times we'll rewrite our compound inequalities with the smallest one first, so that would turn into negative 2 greater than x greater than 6 and 2/7. What other questions from the test? 14. Is the absolute value of k minus 4 is greater than 3. So, what do we need to do? Okay, what's the positive one going to be?
K minus 4 is greater than 3.
And the negative one is going to be what?
K minus 4 is greater than -3.
No.
Negative K.
No.
Parentheses.
We didn't actually do it this way in class, but if you did do it this way, we negative K minus 4 is greater than 3. When we divide both sides by -1, what happens to the inequality? Flips. We actually changed them to equals in class. But. Now what? Add 3? Add 4, right? Okay, it's greater than 7. K is less than 1. Now what? Okay. Now what?
The 0 to the far left. And count out 1 to 7.
Okay. Now what?
Open circle.
Open circles. Okay.
Shade to the right for both.
You need to check all the, check a number less than 1, a number between 1 and 7, and a number above 7.
That's true. What number do we want to check over here?
0.
0. -1 would also work to check. But 0, absolute value of -4 is what? 4. 4 greater than 3?
Yes.
Definitely
I
yes.
forgot that. Okay, changes it.
What are we going to try here?
4.
That's fine. 4 minus 4 is 0. Absolute, what's the absolute value of 4? Excuse me. Absolute value of 0. 0. Is 0 greater than 3?
No.
No. Now what? 8? Sure. 8 minus 4 is what? 4. What's the absolute value of 4?
4.
4. Is 4 greater than 3?
Yes.
Yes.
I got it. It says it's right, but it's wrong.
Well, then either I made a mistake in your favor, which you can keep, but yeah, you got lucky.
Wow.
Actually, is this 14?
This was 14, yes.
How did I get 7?
7 is right.
Oh, and I got 2 7s.
What?
I got -7.
Oh, you got set twice. You did made some sort of sign error, I'm sure.
Can we do 7?
Can we do 7? Sure. Seven is 8 minus. Yeah, think I don't know how many, but I had more than one of you make an old error. An error from a long time ago. Okay, what should we do? We should subtract 8, not add 8. The 8 isn't negative, this is, right? So we subtract 8 and get negative m over 3 is greater than or equal to, what's 11 minus 8? 3. Now what? What do we end up with?
M is less than or equal to negative.
Yeah, it switches because we multiplied by negative, right? We graph it. What?
5.
What did you get?
Oh, I know it is.
Yeah.
I don't know.
I figured that I figured you could find the mistake if I had to guess what your mistake was.
I don't know what I did wrong.
I also.
It wasn't what I think.
It wasn't what you're thinking? What did you get?
B is greater than negative 50.
Yeah, it should have been less than, because it flips. You were right. That's what you did wrong. So you shade to the left.
Can I have a whole ledger?
So I just
This one is really terrible, but you can see what you can see. There's also a better one next door.
Okay.
Maybe. 4. Yeah. Yeah, 1/3 C. When you divide by 1/3, that would be the same as multiplying by 3. Yep. All right, let's start talking about systems.
Can you do number 13?
Number what?
13.
13? Are you sure you actually need it? It's the same as 14. Why don't you give that one a shot? Why don't you give that one a shot, and if you get stuck later, then ask about it. Remember that the point of corrections is to re-engage with the material to make sure you know it, not just to copy what I do, right? All right, graphing systems. What? You only graphed one system? How do you feel about that? Okay, what numbers did we do? 2 through 14.
What's the 6th one? Yeah.
The one that you did, like,
Okay. Yeah. Yes. Yes.
Wait, is it finally the day?
It's finally the day. We finally caught up to you. Let's see whether you understood. Number 2 is consistent and independent. Number 4 is consistent and dependent. Number 6 is consistent and dependent. Number 8 looks like this, and it has one solution at -1, 2. Number 10 is somewhere. One solution at 0, -3. Number 18 has no solution. 18 has no solution. Yeah, that's true. I don't know. No, hold on. 10 is somewhere. Where is 10?
10 is also.
There it is. Consistent and independent. I was reading the wrong numbers. Great. Thanks. Oh, I see. Okay. Number 10, consistent and independent. Number 12 is inconsistent. Number 14 is consistent and dependent. What questions do we have?
Wait, what was 4?
4 was consistent and dependent. We can do number 4.
I think no solution because I thought the only things it could be is the ones on this. I don't know.
I also thought it was infinite solution.
Okay.
No solution on one. I thought that was the only answer.
Number 4. Use the graph to right, although I'll graph it real quick up here. Y equals x plus 3. And x minus y equals -3. So, if we were to graph these by hand, they gave us the graph, but if we were to graph these by hand, this one's set up, this one's not. What do we need to do to make this graphable?
Y equals x or
That
slope
way.
intercept form.
Yeah, slope intercept form, y equals mx plus b. So let's do that real quick. So to do that, what do we need to do?
Subtract or add x.
Subtract, you were right, because x is positive, the y is negative.
Okay.
Minus x. So we've got negative y, don't forget to bring down the negative, equals negative x minus 3. Now what would we do?
-1.
Divide by -1, and we end up with y equals x plus 3. What do you notice about equation 1 and equation 2?
They look kind of same.
They're the same, so it's what? Infinite solutions, but that wasn't one of the options. Dependent and dependent. It does have infinite solutions.
I put no solutions.
Consistent and dependent. If it's the same line, it's infinite solutions. If they're parallel, it's no solution, which gives you inconsistent, right?
I did this in my head, so I got it wrong. I didn't know that I thought these were the only things you like this one if it was like that. If it was like straight line, it had to be like consistent and independent. If it was cross, it had to be consistent. I thought it was like had to be those two only.
No, there's 3 possibilities.
I don't
Because it'd be the same line.
Got you.
I don't even remember how this is done, so I probably should go home and watch it again.
It's
because
just vocabulary and understanding what the solution to a system is. Because after this lesson, we will never solve a system this way ever again. Because it's a stupid way to solve systems. But I don't omit this lesson because understanding the solution to a system is useful. Because later when you hit it next year in geometry and you're like, okay, we got to find this line over here or whatever. Oh, well, that's going to be a system, and then because that's the solution. So understanding what this is important, but just it's helpful right now, but it's not a good way to get a good number. Yeah?
Yeah.
Easy money?
Yep.
Any other questions?
Maybe just do it.
We can do 8 real quick.
Let's do it.
It's going to be annoying to do on the whiteboard, but we'll give it a good shot. Give it a good go. Okay, so number 8, we're going to graph the system and determine the number and types of solutions it has. If it has 1, name it. Name it and claim it. Number 8, we're going to solve the system y equals x plus 3 and y equals 2x plus 4 by graphing. So, what do we need to do?
Nothing, because they're already.
Right? Just go straight to graphing. Yippee skippy. The only system you'll need to graph on the test will be a system of inequalities. You won't solve any by graphing on the test. You'll solve it either by substitution or elimination.
Both of those are better than this.
What?
Both of those are better.
They are if you want to actually find the answer without guessing.
So true. I don't know. Actually.
Great. It is. And I need to see like precision so on this particular one, so actually needs to matter. Okay, so to graph the blue one, what do we do? Start at 3. 1, 2, 3. Up 1 over 1. Great. Connect the dots. Great. Now for the orange one, what do we do?
Go up 4.
Up 4, and then count up 2 over 1. 2 over 1. Connect the dots.
That's exactly what I did. Straight lines are parallel.
Well, they don't have the same slope, so they're definitely not parallel. So something happened there.
Maybe I just like didn't do the line straight. I did do it straight, but I used I had multiple lines. And
Looks like you counted the slope ugly on. You should have used graph paper. It would have been better. How many solutions does this have? 1. And so it's what? Consistent and independent. True. What is the solution?
The solution is -6 and 1.
Definitely not.
Yeah, I don't know.
Coming back.
One, 2.
So on my graph, it kind of looks like it's -2, 1. But I don't know. Which is why this is a stupid way to solve this. Let's solve it with substitution real quick. Nope, that's wrong. Because it's -1, 2. So the actual answer is -1, 2. Well, look at you. I did it right too. It's just like less precise and it's harder to tell.
Cheers.
Yeah, cool beans. Makes sense? Any questions? Okay, let's take a quiz.
A quiz. We haven't taken a quiz ever.
We haven't taken a quiz in a long time.
That's true.
We only did like 2 quizzes, or one. Only 2 quizzes in.
No, if it's not, what if it's not inconsistent? What is, like, how do you know if that's
If it crosses once, if it has one solution, it's consistent and independent. If it is the same line, it is consistent and dependent. And if it never crosses, it's inconsistent. That's it.
solution inconsistent?
Quiz 6-1, page.
So technically I got all those right. Yeah, I got all those.
Except that one, because you said no solution instead of infinite solutions. But
Well, all of them is no solution. The straight line ones don't have any, right?
parallel ones have no solution. That's true.
So I was right.
No, on the one on number 4,
Okay, not number 4.
yeah.
one number from 14.
Oh,
You know what? I'm just gonna get space stuff.
There you go.